This is Lecture 10 in the Fiber Optic Association lecture series on fiber optics. This is our second lecture on fiber optic network design, discussing planning the network. Once we've determined the need for a fiber optic network, we now have to start doing the serious planning. We have to decide what kind of communications equipment types are to be used, where the links will be going, how long will they be, where the cable will be placed, and where the intermediate splices and terminations will be done, what testing is required, what documentation is necessary, and what standards are relevant to this particular project. The next step is to establish the route of the link, to determine the path from point A to point B that our network will run, how far it is, and what obstacles are in its way. On an outside plant link, we might do that on a satellite photo like we show here, and on a premises link, we would do it on a CAD drawing of a building. Then we want to determine the communication needs so we know what kind of equipment will be run on this network. Next, we'll want to map the route out in great detail. We'll review the prints or maps and survey the site in person. We want to do it in person and take pictures, so we'll have records that we can refer to later on in the planning process. It's necessary to determine the exact cable path and length, determine the location of splices and termination, and what hardware are going to be necessary to support those. We're going to do a loss budget, and we'll talk about that more in a minute. And then we'll start looking at timing of the pull, how long it will take us, when we need components on the job site, what special equipment we're going to need for installation, and the like. For every project, we're going to create a documentation package. It is impossible to overemphasize the importance of documenting the project. At the design level, for estimating, installation, testing, troubleshooting, and restoration. Every part of the process depends on having very good documentation. The communications equipment will be chosen to meet the communication needs of the user, whether they be a telco, a cable TV company, a utility, the military. All their needs can be quite different. So the communications equipment must be carefully specified by the customer, and then it will be looked at for compatibility with the cable plant. The designer should understand how fiber optic data links work. With the exception of fiber to the home, which only uses one fiber, most fiber optic data links transmit over two fibers, one in each direction for full duplex transmission. The transceivers are used to convert optical to electrical signals and vice versa. They use lasers or LEDs as transmitters and photodetectors to convert optical signals back to electrical signals in the receiver. As the transmitter sends a signal down an optical fiber, the signal amplitude is attenuated by the attenuation of the optical fiber and reduced by the loss of connectors or splices. So what we are interested in is the amount of receiver power we have. For any given link, the performance of a data link is going to be determined by its bit error rate, or the number of bits received in error. And that is a function of received optical power. It must have enough power for an adequate signal-to-noise ratio, but not so much power that the receiver is overloaded. For each network, we know how much loss it can sustain over a link. So what we do is we calculate out the projected loss of our cable plant and compare it to the dynamic range of the link itself. That way we know if we have adequate amount of power when we get to the receiver. We call this a link power budget, and we do it for every network we design. For very long networks, we may also have to consider chromatic dispersion or polarization mode dispersion or even multi-mode fiber dispersion in premises links. Typical fiber optic link requires a lot of hardware. In the outside plant, it's splice closures and controlled environment vaults and regen huts and pedestals. And in premises networks, it's wall or rack-mounted patch panels and wall outlets and cable trays. The type of hardware we need and the location of that hardware is a very, very essential part of every network design. And it's one of the reasons that we said earlier it's important that you do a site visit, you know exactly where everything is, and you've got pictures to refer back to for your design project. We're the Fiber Optic Association, the professional society of fiber optics. For more information on designing fiber optic networks and other technical topics, refer to the FOA website, particularly the online fiber optic reference guides that will give you technical information on every subject on fiber optics.